Good morning, class. We are looking at chapter 3, derivatives. Here, section 1, 3.1, derivatives and rates of change. In this chapter, chapter 3, derivatives, we're going to look at derivatives and rates of change. The derivatives as a function, basic differentiation formulas, the product and quotient rules, the chain rule, derivatives of the log functions, differentials. In these two sections, we go with the definition. As of section 3, we go with basic differentiation formulas. We cannot use it yet, and we're going to use one of these formulas, which will be discussed shortly. Recall, limits of functions at finite numbers, finding limits by numerical and graphical methods. Here's the definition. The limit of f of x as x approaches a is L. If the limit is equal to L, we say that a sub n converges to L. If it's infinity, negative infinity, or does not exist, it diverges. And of course, to find limits, I simply plug in. Now, in all of these cases, we are trying to find the limit of f of x as x approaches a. Left and right, in all three cases, give us the y value L, and that means the limit of f of x as x approaches a is L. What's the difference? This one, f of a is L, makes it continuous at a. This one, f of a is something else, b, makes it discontinuous at a. And this one, f of a is missing, that means it's undefined. Nevertheless, in all three cases, the limit of f of x as x approaches a exists, and it works out for the limit. Definition of a horizontal asymptote. The limit of f of x as x approaches negative infinity or positive infinity is L. We say y equals L is the equation of a horizontal asymptote. The limit of f of x as x approaches either a or a from the left or a from the right is infinity or negative infinity. Then we say x equals a is the equation of a vertical asymptote. And finally, the limit exists if one-sided limits are identical. The limit of f of x as x approaches a from the left equals L, and limit of f of x as x approaches a from the right is L. Then the limit of f of x as x approaches a equals L. Section 3.1, derivatives and rates of change, tangents. Given y equals f of x, and one point P with coordinates a, f of a, the slope of a secant line PQ, the blue line, is average rate of change or average rate of change of y with respect to x, or m of PQ is rise over run delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That means the same thing. So they are all the same formula so far. Now, if you use f of x and f of x, then you can say f of x minus f of a over x minus a. What I'm trying to say is that this is the same good old rise over run. If we go with this one, and this is point A, and we move by h to the right, now this one is a plus h, so the run is h, and the rise is f of a plus h minus f of a plus h minus f of a. This is the same formula. However, normally we use this one for dq difference quotient, and we take a limit as h goes to 0 to evaluate the derivative. Now, if you call this point x has coordinates b, therefore the y coordinate is f of b. Now, this becomes f of b minus f of a over b minus a. I want you to pay attention to all of them and see ultimately they mean the good old slope of a line. Now, what's happening here? The secant line, which is the blue line, is the line PQ, and we are moving it to get closer and closer to the point P, and the blue line becomes the red line, which is what? The tangent line, the red line, is the limiting position of secant line PQ as Q approaches P. A tangent line is a line that touches a curve at a specific point without crossing it. Slope of a tangent line, also known as instantaneous rate of change. Slope of a tangent line is the slope of a secant line PQ as Q approaches P. So as Q approaches P, the line secant line becomes a tangent line, this slope becomes the slope of a tangent line, and if you use this one, the limit of f of x minus f of a over x minus a as x approaches a, as x approaches a. If we look at this one or that formula, that's the limit as h approaches 0 of f of a plus h minus f of a over h. So the h is approaching 0. And so f prime of a, or the slope of a tangent line at a, has these two definitions: the limit of f of x minus f of a over x minus a as x approaches a, or the limit of f of a plus h minus f of a over h as h approaches 0. They both mean the same thing. Now, to find the equation of a tangent line, I remind you that lines have the following format: standard form ax plus by equals c, point slope y minus y1 equals m times x minus x of 1, slope intercept form y equals mx plus b. So we want to find the equation of a tangent line at this point, okay, this point. And now this point has coordinates a, f of a. This point has coordinates a, f of a. So y minus y1, that means y minus f of a, equals m. F prime of a is m. X minus x of 1, x minus a. Now, do you have to memorize this formula in this format? No. Just remember the point slope from elementary algebra and you're fine. Rates of change, the difference quotient. And again, this is the graph of a function y equals f of x. We want to go from point coordinates x sub 1 and f of x sub 1 to point x sub 2, having coordinates x sub 2 and f of x sub 2, giving rise to the blue line, which is the secant line. Delta y over delta x, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 is called the average rate of change of y with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ, the blue line. We recognize the following limit as being the derivative f prime of x sub 1. They are all the same. Instantaneous rate of change, the limit of delta y over delta x as delta x approaches 0. So if you look at rise over run, when you make delta x closer and closer to 0, you get closer and closer to the red line, which is the tangent line. Or the limit of f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 as x sub 2 approaches x sub 1, x sub 2 approaches x sub 1. Or limit of f of x minus f of a over x minus a as x approaches a. Remember, we call this a and we call this x. So if you call that, this one is x, this one is a, we are looking at this definition. I'm sorry, I mean a and x. Actually, erase. This is a, this is x. And we get to this definition. If we say instead of delta x, it's h, then we go to this definition. And the limit of f of a plus h minus f of a over h as h approaches 0. So The derivative f prime of a is the instantaneous rate of change of y, or f of x with respect to x when x is a. And so we have f prime of a in two different formats that has been discussed. Average rate of a change is m of pq, the blue line. Instantaneous rate of change is m of the tangent line, the red line, or f prime of a, in short. Find the average rate of change of f of x equals x squared minus 3x from x equals 2 to x equals 4. First and foremost, I want to look at something very basic like elementary algebra. Even if they don't mention average, we have 2 points, and that means average. So rise over run. So in short, f of b minus f of a over b minus a, which means f of 4 minus f of 2 over 4 minus 2. That's the good old slope when 2 points are given. So you plug in 4, you get 4 squared minus 3 times 4, minus, you plug in 2 squared minus 3 times 2, over 4 minus 2, which is 2. So this is 16 minus 12, which makes it 4. This is 4 minus 6, which makes it negative 2. So we have 4 plus 2, which gives us 6 over 2 equals 3. Very simple. Find the instantaneous rate of change of f of x at x equals 4. Now, we are going to use f prime of a, and to do so, we can use one of these formulas, this one or this one. For now, we're going to use this. In fact, I'm going to do both for practice. So we want f prime of 4. By the way, even if they don't mention instantaneous, the fact that you have 1 point, that means instantaneous, class. 2 points means average. 1 point means instantaneous, even if they don't say so. We want f prime of 4, replace the a with 4. And so now we are going to use the function. F of 4 plus h means 4 plus h squared, minus 3 times 4 plus h. F of 4, again, means this one, which is 4. So let's write it for now. But this part, everybody, we've done it. So this we know already is 16 minus 12, which is 4. But what is 4 plus h squared? I remind you something that you should know. A plus minus b quantity squared is a squared plus minus 2ab plus b squared. So this one is 4 squared, which is 16, plus 2 times 4 times h, which is 8h, and this is h squared. Minus 12 minus 3h, and finally this 4 gives us minus. We look at the numbers, and the numbers only for now. In one shot, 16, negative 12, and negative 4, they add up to 0. We get 5h plus h squared, so we factor out the h. We can drop the h. Now, it is important to know that we don't have 5 plus h. We have the limit of 5 plus h as h approaches 0, so you can replace it. Please understand, you don't want to write 5 plus h equals 5, which is a wrong statement, okay? Because it's not. But the limit of 5 plus h as h approaches 0 is 5, which is a correct statement. Don't mix them up. You have to carry the limit. What you can do is to evaluate this one, this one, this one. And then when you simplify to 5 plus h, now say limit of 5 plus h as h approaches 0 and apply that there. All right, let's look at f prime of a, and using this formula for practice, you don't have to do both again. So what is f prime of 4? Limit of f of x minus f of 4 over x minus 4 as x approaches 4. What is f of x? X squared minus 3x. What is f of 4? Since we have evaluated, we just write down minus 4. If you plug in, you do get 0 over 0, everybody. And again, understand, it is the 0 in the denominator which is terrible and we want to get rid of. Remember, you do the factoring. The denominator doesn't need factoring. You're hoping it has a factor of x minus 4. It does. But the numerator, now that you want to get rid of x minus 4, you should have a factor of x minus 4. And you do. You want two numbers. The product is negative 4. The sum is negative 3. That makes it negative 4 and plus 1. These two cancel each other. Limit of x plus 1 as x approaches 4. As we plug in 4, we get the same answer. And that's the idea. Again, you don't have to do both ways. One is good enough. We want to find an equation of a tangent line to the parabola y equals x squared at the point 1, 1. They don't have to give you a pair. They can give you x. It's important. X is 1, plug in, you get 1. X is 2, plug in is 4. X is 5, plug in, you get 25. X is negative 4, plug in, you get 16. So if they give us x, that's good enough. What else do we need is the slope. So we need to calculate the slope. Why? In order to come up with the equation of any line, you need the pair, it's given, and the slope we need to calculate. So we are going to use one of these formula, knowing a is the x coordinate, which makes it 1, and the function y or f of x is x squared. We're going to find the slope, and there are two ways. Which way are you going to go? For practice, I'm going to go both ways. With this one, you really have to know both ways, because ultimately this is the main method that is used for the next section. But as long as you know what you're doing, either one will do the job. When you do the homework or any assignments, make sure you follow the instructions. So f of x, you replace it with x squared. F of a, you can plug, of course, a is 1. A is 1. So you can plug in 1, or the y coordinate is given as 1. You don't have to evaluate it, it's given. And again, you have to factor. Before you do that, please notice if you plug in, you get 0 over 0. And obviously, to factor, again, I'm reminding you all the identities here that you are supposed to know. I hope you all know that. Okay. So x squared minus 1, and by the way, 1, or you can say x squared minus 1 squared, because 1 squared, 1 cubed, that's the same thing. So therefore, we are going to use this one. We get x minus 1, x plus 1. Common factor of x minus 1 drops. Replace the x and you get through. This is your slope. Slope of what? Tangent line. Slope of a tangent line. Y minus y1 equals m times x minus x of 1. So y minus 1 equals m, which is 2, x minus x of 1, which is also 1. That's why I said you don't have to memorize the formula that was given. Remember, the formula was y minus f of a equals f prime of a times x minus a. You don't have to memorize that, just use the point slope. So this is 2x minus 2. You move this, you get 2x minus 1, and you're done. You can check with the pair. When it works, that means this process was done right. Doesn't mean anything else. I'm going to use the second method, which means I'm going to find this slope again. I'm not going to go through that process, just the slope. And of course, a is 1. So f of the limit of f of 1 plus h minus f of 1 over h as h approaches. You can always evaluate this fraction, simplify, and the end, then you say limit of that simplified version. You can always do that, okay? So you can calculate this, simplify. Or you can calculate f of a, you can calculate f of a plus h step by step. And so we have the following: 1 plus h squared. If you plug it into this and following this method, you get 1 squared, which is 1, 2 times 1 times h, which is 2h, and h squared. Now 1 and negative 1 cancel each other. These two, we factor the h out. H and h cancel each other. Now limit of 2 plus h as h approaches 0. Again, you must have the limits, so plug in 0, otherwise you can't. When we plug in 0, we get 2, which is the same number we found here. So we can easily see the answer. We want to find the derivative, also known as instantaneous rate of change of f of x of the function f of x equals x squared minus 8x plus 9 at x equals 5. In the next section, we can find f prime of x and then replace the x with 5. And after that, we can take the easy way out using formulas. But for now, we are going to do by definition, which means f prime of 5 is limit of f of 5 plus h minus f of 5 over h as h approaches 0. One of these methods I'm going to use, and the second one I leave it for you to practice. So again, what you can do f of 5 plus h, write it and simplify it. F of 5, simplify it. Their difference, simplify it over h, and then finally take a look. But I like to do all of it in one shot, which means f of 5 plus h, I'm going to put it into this, and I get 5 plus h quantity squared minus 8 times 5 plus h plus 9 minus f of 5, that means 5 squared minus 8 times 5 plus 9, and I separate them by parentheses or brackets. Now, of course, I have to simplify each one, starting with 5 plus h squared. Using that, we get 5 squared, which is 25. 2 times 5 times h is 10, h plus h squared, minus 40, minus 8h, plus 9, minus, this is 25, so minus 25. This is 40, minus and minus, plus 40, and minus 9. The reason I do it this way, the more proper way is to simplify this one in one shot. However, notice when I write it in this format, what happens to the numbers. This cancels out this one because they're opposite. This cancels out this one because they're opposite. This cancels out this one because they're opposite. So there are no numbers left. Then I notice these two give me 2h, and that's all there is left in the numerator. 2h plus h squared. So you could have simplified the numerator to 2h plus h squared. Then you put it at top of h. You are going to factor the h out to get 2 plus h. This h cancels out this h. You get the limit of 2 plus h as h approaches 0. Now that you apply, you can lose the limit. You cannot lose the limit until you apply the limit, and it becomes 2 plus 0 or simply 2. And I highly recommend you use the second method, meaning this one, to come up with the answer as practice. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What's the average velocity of the object from 2 to 4 seconds? Again, when we are given 2 points, that means average, even if we don't say average. So what is the average velocity? The average velocity, in short, is the total distance, which is s of t2 minus s of t1. The difference between the two is the total distance covered over the course of the given time interval, over divided by the total time, t sub 2 minus t sub 1. So I hope you remember from elementary algebra, we said d equals rt, okay, where r was the rate or speed. So total distance over total time, and in this case would be s of 4 minus s of 2 divided by 4 minus 2. So elementary algebra, plug in 4 evaluated, plug in 2 evaluated for the numerator. So we have 2 times 4 squared minus 5 times 4 plus 40. This is this part. Minus, we plug into 2 times 2 squared minus 5 times 2 plus 40. This is 16, making it 32 minus 5 times 4 is 20 plus 40. So this becomes 52. This is 4, so it's 8 minus 10 plus 40. This is 38. So 52 minus 38 is 14 over 2 or 7 feet per second. Again, how do we find the units? Anytime you have applications, if units are given, you give them back with the units. The units of the numerator over the units of the denominator. S of t2 minus S of t1 is in feet, over t sub 2 minus t sub 1 is in seconds. So feet per second, always with units. Now, what is the instantaneous velocity of the object at 4 seconds? Even if they don't mention instantaneous, it means at 1 point. Okay, 2 points versus 1 point instantaneous. So we have to take the limit. So v instantaneous is s of a plus h minus s of a over h as we take the limit and h goes to 0. So the limit of s of a plus h minus s of a over h as h approaches 0. And what is the value of a? A, whatever is given here. 1 point is given, namely a is 4. Replace the a with 4. Now let's evaluate. And to do so, 2 times t squared becomes 2 times 4 plus h squared, minus 5 times t becomes minus 5 times 4 plus h plus 40. So that's this. S of 4, plug in 4, 2 times, actually S of 4, you can evaluate it, okay? Or easy way out. We've already done that. S of 4 is already done that. I'm not going to bother to waste time, so I'm going to use that 52. Okay, the 52 comes from here. S of 4, I'm using what we've done already. Okay, So again, pretty straightforward. I hope everybody's fine with that. So what do we do next? Simple. Let's erase this to the power, let's raise this to the power of 2. 4 squared, again, using this. 4 squared is 16. 2 times 4 times 8 is 8h and h squared. That's the first thing. Now let's multiply this by 2. We're going to multiply this expression by 2. We get 2 times 16, 32, plus 16h plus 2h squared minus 20 minus 5h plus 40 minus 52. Okay, we want to make sure that we know what's going on. Okay, very straightforward. First and foremost, look at the numbers, class. Number 32 minus 20 plus 40 minus 52, they add up to 0. They cancel each other because it's really 72 minus 72. So take a look at that. So we have 2h squared, and we also have 11h because 16h minus 5h, they combine into 11h. And so if the numerator simplifies it to 2h squared plus 11h, we can factor out the h. These two cancel each other. And now it's time to plug in h equal to 0. And we get 11 feet per second, the same unit that we have for the average velocity, because this means dv dt. Let me write that so you know that. So the formula here, this one also is written as dv divided by dt. So it's the same units, changing ds, my apologies. I thought ds, change in distance over change it. So that's why they have the same unit as we had it here. All right, we want to find an equation of a tangent line to the graph of this function f of x equals square root of x at the point 16, 4. Again, please notice if I plug in 16, I get 4. They may not give you the pair. They may give you x if, just to make sure we understand this, if let's say, if they said x is, I'm making it up, 9, then you should know it's 9 and 3 because square root of 9 is 3. If they said x is, I don't know, 100, you should recognize the square root of that. So that's 110. Okay, so they don't have to give you the pair, the first thing. And of course, in this case, a is 16, f of x square root of x, and I'm going to erase this. We are going to use one of these formulas to find the slope because we are given the pair and we need the slope. So if I use this one, and by the way, for practice, we're going to look at the second method also. So f of the limit as h approaches 0 of f of, replace the a with 16, 16 plus h minus f of 16 over h. That's what we are going to do. All right. So what is f of 16 plus h? Is square root of 16 plus h. What is f of 16? You can use the 4. On purpose, I want to use square root of 16, and here's the reason. Let's assume it wasn't a perfect square. It was 15, and then you have to write square root of 15. That's why I'm writing it in case. So you see, we will get rid of that. So even if it's not a nice and easy number, that's fine. So keep it as square root of 16. If you plug in, of course, you get 0 over 0. And the technique is to multiply by the conjugate. Again, first you have to plug in. You do get 0 over 0. And because you get 0 over 0, the conjugate, which means just the sum here, square root of 16 plus h plus square root of 16, you put it in the numerator as well as the denominator. So what happens? The denominator, you don't touch it, it's a product. The numerator, when you multiply these two, you get the first one squared, that means 16 plus h squared, minus the second one squared, and it becomes 16 plus h minus 60. Obviously, these two cancel each other. The h from the numerator and the denominator cancel each other. And now if you plug in 0, you get square root of 16, which is 4, plus square root of 16, which is another 4, and you get 1 over 8 as the final answer. See, now that you plug in. Y minus y1 equals m times x minus x of 1. That means y minus 4 equals 1 over 8x, my 1 over 8 is here. X minus x of 1, that means x minus 16. And now all you have to do, distribute, and here's what happens, everybody. We're going to get 1 over 8 times x minus 2. Needless to say, we are moving negative 4. And the final answer is y equals 1 over 8 times x plus 2. Now, the only thing I want to add before we look at the second method, if you plug in 16, you get 1 over 8 times 16, which is 2 and 2, 4. When it checks, it means this process is correct. It doesn't mean that we came up with the correct answer here, okay? But it's a good idea to do that. Now, the slope was 1 over 8, and we use this. We are going to use the first one now for practice. Again, for practice and practice only. Therefore, m or f prime of a, in this case, f prime of 16. M or f prime of 16 is the limit of f of x minus f of 16 over x minus 16 as x approaches 16. So all you have to do, replace the f of x with square root of x, and f of 16, since it's given now with 4. And please understand, if you plug in, you do get 0 over 0, as we did here, okay? So the technique is the same technique. Multiply by the conjugate of the numerator, which is square root of x plus 4. And when you do that, this gets squared up, comes out, and this gets squared up, becomes 16. So x minus 16. And remember, in the numerator, we do that, but in the denominator, we don't do anything. We keep it as a product. Therefore, this piece cancels out this piece. You have 1 over square root of x plus 4. And so the limit of 1 over square root of x plus 4 as x approaches 16, if I replace now with 16, I get 4 and 4, 8. Both of them give me the answer. Which one is easier, you decide. But you need to practice and be able to do both ways if need be. The height in inches, example 6, is from review exam question 39. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. Of course, we want to include proper units. How tall is the sunflower 8 weeks after planting? I hope you realize this is elementary algebra. So simply put means plug in 8. So you want f of 8. That's all you're interested in. We are interested in finding f of 8. Okay. So 6 times 8 minus 1/4 times 8 squared. This is, of course, 48. This is 64. 1/4 of it is 16. The result is 32. And the units, 32 inches. The units, 32 inches. It's elementary algebra, where part B is also elementary algebra. We want to find the average rate of growth from the end of week 6 to the end of week 12. Average. So delta y over delta x. F of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. In this case, f of 12 minus f of 6 over 12 minus 6. So basically, plug into this formula x equals 12. You get 6 times 12 minus 1/4 of 12 squared. Plug in number 6 minus 6 times in the brackets or parentheses 6 times 6 minus 1/4 of 6 squared. So you have 72 here. This is 144. So 1/4 of it is 36. You have 36 here. You have 36. 1/4 of it is 9. So we have 72 minus 36 here. Minus 36 minus 9. Actually, minus 36 minus 36, they cancel each other. Minus minus 9 is plus 9. 9 over 6 is 3/2. And units of the numerator over the units of the denominator, inches per week. F of x sub 2 minus f of x sub 1 is in inches. X sub 2 minus x sub 1 is in weeks. So 3/2 of an inch per week. So on the average from week 6 to 6/12, this is the growth rate. It doesn't mean that it happens every week. 1 week may be more, 1 week may be less, but on the average, that's what happens. Now, find the instantaneous rate of growth 10 weeks after planting. And I'm reminding you from the previous page that the function f of x is 6x minus 1/4 x squared. Now, it's calculus. We use one of these formulas. Okay, you can use any of it. I'm going to use one of them, and then for practice, you do the other one. So f prime of a is the limit of f of x minus a minus f of a over x minus a as x approaches a, where a is 10. So f prime of 10 is the limit of f of x minus f of 10 over x minus 10 as x approaches. So what is f of x? You just write this. You don't have to do anything. Minus, what is f of 10? Replace the x with 10. That means 6 times 10 minus 1/4 at 10 squared. So one more time. You put f of x just the way it is, minus f of 10, 6 times 10, minus 1/4 10 squared, and the bottom again, x minus 10. So I hope you realize it's all about algebraic techniques, being able to simplify the numerator as follows. This is 60, this is 100, 1/4 of it is 25. So let me just write this. So this is 60, everybody, minus this is 100. So 1/4 of it is 25. So you're talking about 35. Now, this is a complex fraction. The reason it's a complex fraction is because of this 1/4. So if I multiply the top and the bottom by 4, I can get rid of the 1/4 to simplify this. So first and foremost, the denominator doesn't change, 4 times x minus 2. But what happens here, you get 24x This one and this one cancel each other. Minus x squared minus 35 times 4. That means minus 140. Minus 140. So that is important to understand. It's pretty straightforward. Now, to simplify this, I'm going to put the numerator in descending order. And when I do that, this comes first. And to factor this, I'm going to get rid of the negative by factoring the negative sign out. So this becomes minus x squared minus 24x plus 140. The numerator is this. And since x is approaching 10, we want a factor of x minus 10. We have it down here. We better have it up there to get rid of it, because the problem is x minus 10, it makes the denominator 0. And so you want two numbers. The product is 140. The sum is negative 24. That makes it negative 10 and negative 14. So this is x minus 10 times x minus 14. Don't forget the negative sign. So what I do, I keep the negative sign. It's not going anywhere, everybody. Now, whether you keep it inside or outside the limit makes no difference. The constant negative 1. And the numerator becomes x minus 10 times x minus 14 over 4 times x minus 10. We want to take the limit as x approaches 10. These two cancel each other. And now, if I plug in 10, I get minus 4 over 4, which gives me 1. And 1 inch per week. 1 inch per week. The units are the units of the numerator over the denominator. Okay, which means what? We want to explain the meaning of the answer to part C. On week 10, the sunflower is growing at a rate of 1 inch per week. 1 inch per week. Suppose that a ball is dropped from the upper observation deck of the CN Tower 450 meters above the ground. So S is f of t equals 4.9 t squared. What is the velocity of the ball after 5 seconds? How fast is the ball traveling when it hits the ground? So we want to find the velocity, and the formula is the instantaneous velocity is the limit of s of a plus h minus s of a over h as h approaches 0. In essence, we are going to move towards this next section. We can find the velocity at 5 seconds. And then over here, we have to figure out the t and then find the velocity at that time. So that means I have to go through the process 2 times. Instead, I'm going to generalize it and find this one, v of a, and later on we're going to say it v of x. So I'm going to keep it at a. I'm not going to change the a. Notice what happens. It's going to be very interesting. It makes it easier to figure out for part B. You don't have to go through the same process. Here's how it works. We're going to keep it as a. So the limit of f of a plus h minus f of a over h as h approaches 0. So replace the t with a plus h. You get 4.9 times a plus h squared minus f of a is 4.9 a squared. Now this part, remember, according to this one, is a squared plus 2ah plus h squared. And because everything has 4.9, we're going to take 4.9 out. 4.9 times this part is a squared plus 2h plus h squared. This one, if I take the 4.9, is minus a squared. Now, clearly, a squared and minus a squared cancel each other. So what can you do with this? You can also take out h, right? And so they cancel each other. So you're left with the limit as h approaches 0 of 4.9 times 2a plus h. So if you let h go to 0, you get 2a times 4.9, which is 9.88, which means at t equals a, v of a is 9.8a. So what is it at t equals 5? Replace the a with 5. And you get 49 meters per second. What about here? How fast is the ball traveling when it hits the ground? We need to figure out the time when it hits the ground. The formula for f of t or s is 4.9 t squared. The distance that it's going to cover to hit the ground is 450. So if you find the distance, which is 4.9 t squared, and set it equal to the given distance of 450, then you can calculate the t. Set this to equal. T squared is 450 divided by 4.9, which is this number. And you take a root and you keep the positive one only, you get 9.6 seconds. We go back to this one, or this one if you will, and we say now A is 9.6 seconds. And so if you plug in 9.6, their product 94.08 meters per second. So to recap, instead of evaluating it at 5, we evaluated at A. For 5, we replace the A with 5. For part B, we have to figure out the T, which is 9.6. We evaluate this expression at A equals 9.6, and we get 94.08 meters per second as the final answer.